Welcome to Impact Signals, social impact at the scale of AI. I'm Charlie.
And I'm Sarah.
It's Monday, March 31st, episode 46. Today, we're diving into the tools that matter most: disaster robotics in Southeast Asia, recovery logistics powered by AI, and open source data infrastructure that's changing how humanitarian organizations work. Let's get into it. We start with a quiet crisis that's not getting enough attention. Vanuatu's latest public health emergency isn't a cyclone or earthquake. It's Ciguatera fish poisoning. Over 2,500 cases reported since the outbreak began, and health facilities are overwhelmed.
That's where AI disease surveillance comes in. Vanuatu's health surveillance system is now using AI to track Ciguatera cases in near real time, identify high-risk fishing areas, and predict where the next cases are likely to appear. It's recovery-focused infrastructure, building back health systems that are more resilient, not just to this outbreak, but to future food safety crises.
The system integrates reports from health facilities across the islands, cross-references them with ocean temperature data and fish catch reports, and flags patterns the human eye would miss. No centralized lab needed, no weeks of sample processing, just structured data flowing into predictive models.
This is what recovery phase AI looks like when it's done right. Not rebuilding the old system, building a smarter one that catches the next crisis earlier. The framework is transferable to other Pacific Island nations facing the same constraints: limited lab capacity, distributed population, high-risk seafood supply chains.
Why it matters for practitioners? If you're managing health emergencies in resource-constrained island nations, this is a replicable model. Data infrastructure first, AI analytics second. Vanuatu's already doing it. Moving to Southeast Asia and a different kind of disaster preparedness. Robotics and AI are converging on disaster response in ways that transform search and rescue.
Constellation Technologies has partnered with Korea's Electronics Research Institute, ETRI, to deploy autonomous quadruped robots across Indonesia and the Philippines for post-disaster damage assessment. We're talking about machines that can navigate rubble, climb stairs, access buildings human rescuers can't safely enter, all while collecting thermal imaging and structural damage data.
The innovation here isn't just the hardware, it's the AI on board. The robots use deep learning models trained on thousands of hours of disaster footage to categorize damage in real time: collapsed structures, hazardous materials, trapped individuals. They feed that data directly to emergency command centers.
And because these are purpose-built for disaster response, they're cheaper and more maintainable than Western equivalents. That matters for Indonesia, which experiences earthquakes almost constantly. The Philippines handle 20-plus typhoons a year. These countries need tools designed for their disaster frequency, not imported from high-income markets.
The real-world test case: post-earthquake response in Mindanao, Philippines, where the system identified 3 structures still harboring missing persons 48 hours after impact, structures that visual surveys had missed. That's the operational relevance: faster rescue, higher survival rates.
Why it matters. AI disaster robotics are moving from research projects to actual operational deployment. If you're running disaster management operations in the Pacific or Southeast Asia, vendor partnerships are forming right now. This is the moment to engage.
To Latin America now, where post-flood recovery is getting smarter.
Colombia's devastated by flooding in the Cauca Valley, 72,000 families affected. Recovery is happening at scale, and AI is handling logistics that would otherwise bury recovery operations in paperwork. WFP and local authorities are using machine learning to optimize debris removal routes, predict where shelter capacity will strain next, and pre-position water and sanitation infrastructure.
The specific innovation, a neural network trained on historical recovery timelines from previous Colombian floods, is predicting how fast each community can transition from emergency shelters to permanent housing. That informs who gets reconstruction funding first, not based on political pressure, but based on realistic recovery capacity.
This is algorithmic fairness in action. Without the model, recovery timelines get determined by whoever has the loudest voice or the best political connections. With it, reconstruction follows data-driven prioritization tied to actual community resilience capacity.
The secondary effect is efficiency. One coordinator with an AI dashboard now does the work of 5 coordinators with spreadsheets. That freed up capacity gets redeployed to the hardest to reach communities, the ones that don't have cell service, reliable transportation, or NGO presence.
Why it matters. Recovery isn't a footnote to disaster response. It's where families rebuild. It's where communities either regain stability or become chronically displaced. AI tools that accelerate and depoliticize recovery are infrastructure investments, not just efficiency gains.
Food security is tightening across the global south, and AI is stepping in as the early warning system.
The World Food Programme released updated food security projections this week for 43 countries in sub-Saharan Africa and South Asia. The model combines satellite vegetation indices, rainfall anomalies, conflict escalation data, and price volatility feeds. The result? Probabilistic forecasts of how many people will face crisis or worse hunger conditions 3 to 6 months out.
The specificity is striking. Not just West Africa faces a crisis. Instead, Burkina Faso, Benue State Region, June 2026, 340,000 people face crisis phase with 70% confidence, emergency phase with 35% confidence. That level of detail lets WFP and partner organizations pre-position cash, seeds, and health screening before hunger spreads.
Why it matters. Anticipatory action works. Pre-positioned aid prevents 30 to 60% more suffering than reactive response. But anticipatory action requires forecasts good enough to justify expensive pre-positioning. This model is good enough. It's being operationalized now.
The funding implication is massive. If governments and multilateral donors can see 3-month-ahead hunger forecasts with 70% confidence, they can build that into budgets. That's the difference between hoping funding arrives in time and knowing it needs to be ready by June. On the infrastructure side, open-source data is reshaping humanitarian AI.
The Humanitarian Data Commons now includes datasets from Microsoft's AI for Good Lab and Atlas AI, over 12 structured datasets on Humanitarian Data Exchange. These cover everything from conflict-affected regions to climate-vulnerable zones to vulnerable populations, all open, all under humanitarian-friendly licenses.
What makes this matter? Most humanitarian organizations can't afford proprietary data platforms. A local NGO in Cambodia doesn't have a $50,000 a year subscription to corporate geospatial data. But HDX? Free, open, usable.
The implication is that AI disaster tools can now be built on a commons instead of gate-kept by vendors. That shifts power and sustainability toward organizations closest to the crises. A team in Kampala can train their own disaster detection models using the same data layers a Silicon Valley startup uses.
Why it matters for practitioners. If you're building AI tools for humanitarian response, open data infrastructure is now mature enough to be your baseline assumption. You don't need to license proprietary datasets. The commons is stocked. Finally, a story about humanitarian principles and digital infrastructure, a convergence that matters more than most realize.
The ICRC is advancing something called the digital emblem, the cyber equivalent of the Red Cross emblem that protects hospitals from attack under international humanitarian law. As humanitarian organizations digitize operations, their databases become targets. Beneficiary registries, medical records, financial transactions, all now vulnerable to cyber attack.
The digital emblem would mark humanitarian data systems as protected infrastructure, equivalent to marking a physical hospital with the Red Cross symbol. Attacking it would constitute a war crime under international law. That's the theory.
The practice is harder. The ICRC is working with the IETF, the Internet Engineering Task Force, to develop technical standards for marking humanitarian systems. How do you cryptographically signal this is a Red Cross medical database in a way that's universally recognized and legally binding?
It's a fascinating question at the intersection of technology and law. But why it matters operationally, any organization running AI systems for beneficiary assistance, health, or protection needs to be thinking about this. If your database gets compromised, what's your recovery playbook? Who do you contact? What liability do you have?
The ICRC is signaling that these aren't edge cases anymore. They're becoming standard operational concerns for humanitarian organizations. That means procurement standards need to include digital emblem readiness.
That's Impact Signals for Monday, March 31st. If this briefing is useful, subscribe wherever you get your podcasts. Check us out at impactsignals.ai and share it with someone working in the field.
Stay ready.